Hello everybody. Today we're going to talk about material testing. So material testing is the idea that we have materials and we want to try and figure out what their properties are. And so I have a couple of different slides here, a couple of different tests that we're going to talk about. So the idea is that we want to create a reproducible test, something that somebody anywhere could test it and get the same results. Two different types. One is called a static test. So we're going to apply a constant load to it and see how it performs. And another one is called a dynamic test. So the idea with this is we have multiple different types of loading. We're going to have a load that cycles back and forth. And another one is going to be where we're testing it to the point of failure. So static material testing, the idea with this is we can test these couple different types of attributes to the material. Strength, how strong it is, deformation, what it looks like after the load has been applied, fracture, how it fails, and then whether it meets the design requirements. Three different types. One is called the tensile test. That's what we're going to talk about a little bit more today. Compression test, where we're pushing on something, and the hardness test is how hard the material is. So the first one, probably the most common one, is called a tensile test, and tensile related to a tension force. What we're going to be doing is we're going to be pulling on a test sample. So this is an example right here of a test setup. With this, we have two jaws. We're going to be putting a small little test sample in here. And then this rig here will pull down to the point that this test sample breaks. We have a little short video here, and you can see that we have a test sample in there. As it gets stretched, it does break. A better video here that I want to show you right here. So we're going to play this, and I can play it at a little bit faster speed. And what you will see is that when this is being pulled, this is the test sample right here. This is the top jaw, this is the bottom jaw, and this is going to stay in place. This other one's going to be pulling down, and as it pulls down, what you're going to see is that this is going to stretch out. And it's right now it's stretching out in a uniform manner. But as we get farther into this, what you will see is that this is going to start deforming irregularly. And as it does that, it's going to create something called a neck. We're going to talk about that in a little bit. As that neck forms, what will happen is that is going to be the point at which we will see that this test sample fails. Pay no attention to the guy in the back with the awesome mustache and safety glasses. So it's currently testing, it's currently pulling. And very shortly, we're going to see right there, that's where the neck is going to form, I believe. You can see we're about 2/3 of the way through. What I'm going to do is after this breaks, I'm going to rewind it a little bit. You're going to see that this has really stretched out. There's our neck, and there's our failure. So you can see that this is the point of failure. I'm going to pause this for a second. What I'm going to do is I'm going to back this up. And what you're going to see is you're going to see how much that does, in fact, deflect. So we have this is our original length. And as we stretch out, you can see that this test sample really has stretched quite a bit. And so this point right here is the point at which failure has occurred. I'm going to go back to our slideshow here a little bit. And the idea with this tensile test is that we are creating something, we're creating a test that tests it to the point of failure. That's the whole point of this type of test. More to be continued in part number 2.